Here's a quick lesson on factoring trinomials. Factoring trinomials might be one of the most important skills we learn to do this year. So when I say we're going to be factoring trinomials, today what we're going to be practicing is dividing an expression in the form of ax squared plus bx plus c. Now you might notice that the a, b, and c are in red. I want you to remember that the a, b, and c will probably not be there in most of the problems we do. In most of the problems we do, the a, b, and the c will be actual numbers. The a and the b are called coefficients because they come in front of a letter that we will see, the x. When I ask you what is the a of an expression in the form of ax squared plus bx plus c, I'm referring to the number in front of the x squared. If I ask you what's the b, you'll tell me the number that you see, including the sign, that's in front of the x. And if I ask you what is the c, that's the number that's all the way at the end that doesn't have any other letter connected to it. So what we're going to be practicing today is somehow transforming, factoring a trinomial. It's called a trinomial because it has three parts, the ax squared part, the bx part, and the c part, into two smaller parts that you see on the bottom in parentheses. Each of those expressions inside the parentheses only have two different numbers or letters. They're called binomials. Trinomials meaning three parts, and binomials meaning two parts. So our goal today is to transform a trinomial into two, or the product or the multiplication of two smaller binomials. Now, in my experience, one of the reasons we have difficulty in this skill is that we are not so sharp in our very, very, very basic skills of adding and multiplying. And when I say adding and multiplying, I'm not talking about any old numbers. I'm talking about numbers that have the same signs, maybe different signs, maybe they're both negative, maybe they're both positive. So let's do a little exercise first before we get to the factoring part to make sure that we're ready to start. So I'm just going to take two numbers. I'll take two pretty simple numbers, the number 2 and the number 7. But what I'm going to do here, so we can practice adding and multiplying, I'm going to put every possible combination of 2 and 7, meaning -2 and -7 will also be involved. So here's what I'm going to do. On the left side here, we're going to practice the rules of adding. So on the first problem, I'm going to put a +2 and a +7. I know they're positive because they either have a positive in front, like the 7 does, or the 2, which doesn't have anything in front of it. We're going to assume that that's also positive. So this would be +2 plus +7. And just so we could see the difference, right underneath it, I'm going to put -2 plus a -7. And then just to really confuse us, I'm going to put down here a +2 and a -7. And then I'm going to put a -2 and a +7. And we're going to practice all the different combinations of adding numbers with different or the same signs. Now on the right side here, you might notice that I put some empty parentheses. Well, I'm going to do the same thing. I'm going to use 2 and 7. And when two parentheses touch, we all know that we multiply. So I'm going to put the +2 and the +7. I'm going to put a -2 and a -7. I'm going to put the +2 and the -7, and then the -2 and the +7. So we could see on one clean page all the different possibilities and try to practice this and not confuse them as often as we do. So why don't you press pause right now and see if you could add, without a calculator, all the problems on the left side, and see if you can multiply, without a calculator, all the problems on the right side. Go ahead. Okay, let's see how you did. Well, I'm sure everyone got this first problem, right? Positive 2 plus 7 is just regular adding 2 plus 7, which is 9. Now, here's where we start getting confused sometimes. What's a negative 2 plus a negative 7? There's lots of different ways to think about what negative 2 plus negative 7 actually means. One way to think about a negative number is, say, money that you are losing or spending. So if I think of a negative number as how many dollars I'm spending, I would say negative 2 plus negative 7 is the same as, well, I spent $2 and then I spent another $7. So in total, how much money did I spend? Well, I spent, there's my negative, $9. So take a look at the positive 2 plus positive 7 and negative 2 plus negative 7, and you might see a commonality there. Well, here's another area where some of us get confused. Well, what happens when I start adding signs that are different? Well, here again, there's a lot of different ways you can look at it. But let's look at the positive number as the money that someone might be giving you, and as the negative number as the number of the money you're losing or spending. And let's just pretend you're starting out with 0. Well, in this first problem, someone is giving you $2. And then you are spending 7. Well, where are you at the end of that exchange? Well, you had nothing. Someone gave you 2, but then you had to spend 7. So I don't think you had enough money. Well, by how much? Well, I did not have $5. You can also look at this in another way. When I see I'm adding 2 numbers with different signs, sometimes in my mind I like to subtract, because really that's what subtraction is, the addition of 2 numbers that have 2 different signs. And I know that 7 minus 2 is 5. But then I have to really be careful about the sign. Well, if you take away the signs, 7 is a bigger number than 2. And in this case, the 7 happens to be negative. So I would say that the negative will win the war between positive versus negative. And in this case, you're going to have a negative 5. Well, if I use that same example in this next one, I say, well, I have a positive 7, a negative 2, and a positive 7. Well, the signs are different, so I'm going to subtract 5. The bigger number is still 7, and in this case, it's positive. So the positive is going to win. Or if we go back to the money metaphor, you have $7 given to you, and you have to spend 2. Well, you still have 5, positive $5. Okay, take a look at those and maybe take some notes to help you remember how to do each one. Well, let's compare them on the same page now to multiplication. Multiplication is a little different. Well, most of us know that 2 times 7 equals, that's right, 14. However, what happens when we take that same 2 and 7 and both of them are negative? Well, some of you are going to remember that when you take a negative and you put another negative, you're going to get a positive. So a negative number times another negative number is also going to be a positive 14. Now you might notice that neither of those numbers have positives in front of them, the 14s. When I don't put a sign in front of a number, we're going to assume that it's positive. Well, down here in the bottom, we still have 2 times 7 and 2 times 7, but in this case, the 2 is positive and the 7 is negative. Well, when the signs are different in multiplication, we're always going to end up with a negative answer. But we're still going to multiply in the same way. It's still going to be 14, but in this case, it's going to be negative 14. And then underneath it, We have a -2 and a +7, and we're multiplying. Again, we have two signs that are different, which means it's going to be negative, and 2 times 7 is 14. So you can see in some ways, multiplying numbers with all different signs is a little bit easier in that all of the numbers have a 14. 2 times 7, 14, 14, 14, 14. However, what you must remember is when you have two positives, it's always going to be positive. When you're multiplying two negatives, it's also going to be positive. And when the signs are different, regardless of which one is positive and which one is negative, the answer or the product will be negative. So let's play a quick little game. The game is called Add Multiply. And all I'm going to do for each one is put two different numbers. For example, 3 and 6. And all you need to do, as quickly as you can without a calculator, is add them and multiply them. So for example, the first problem would be 3 plus 6, which is 9. And then here in the last spot, it would be 3 times 6, which is 18. Pretty simple game, right? Okay, but now I'm going to mix up some numbers and mix up some signs. So I'm going to put in the numbers, and then you're going to press pause and see if you could add them and multiply them. So here I'm going to put 2 and a -5. Here I'm going to put a 7 and a -3. That's why not put a -5 and a -6. Here on the other side, we'll do some more. Let's see. How about a -1 and a +1? How about a -8 and a +5? How about a 4 and a 9? And how about a -10 and a -3? Go ahead, press pause, and for each problem, see how fast you can add them and multiply them. Okay, let's see how you did. 2 plus -5. 2 times -5. 7 plus a -3. 7 times -3. -5 plus -6. -5 times -6. -1 plus 1. -1 times 1. -8 plus 5. -8 times 5. 4 plus 9. 4 times 9. -10 plus -3. -10 times -3. And there you have it. The add 'em, multiply 'em game. Why not try some numbers on your own? Try it at home, try it with a friend. See if you could add any types of numbers and then multiply the same two numbers. Because if you can become an expert at adding and multiplying any types of numbers, then you can also be an expert at factoring trinomials. So let's get to it. Here we go. Factoring trinomials, the first key to the math universe. This is such an important skill that we're going to use for the rest of the year, and you're probably going to use it for the rest of your math lives. So here you go. Let's take a look at these two problems. You might notice that these are two trinomials. And if you remember at the beginning of the lesson, we said what we're going to try to do is to divide these trinomials, these three-part expressions, into two binomials that are multiplying. The factors, two factors in the form of binomials. Here is Mr. Frank's method. Well, if I know that I have a trinomial and I know that my goal is to create two binomials, I'm going to start with opening two sets of parentheses. I'm going to do both of these at the same time so you can see one extremely important difference in them. Both of these trinomials look very, very similar. X squared plus 12x plus 20 and x squared minus 12x plus 20. Well, while they look very, very similar, you can see that there's one very important difference. One of them has a b that's positive, positive 12, and the other one has a b that's negative, negative 12. Let's see how that affects our final answer. So we're going to start with the x squared. Well, there's only one way that we're going to separate an x squared into two factors. And that is x times x. And I'm going to do the other one at the same time. The only way we can get x squared is x times x. Now, this next part is extremely important. The next part is jumping to the last number and circling the sign. In this case, it's positive 20. In the other case, it's also positive 20. Now you have to go back and remember for this last number the rules of multiplication. If you remember correctly the rules of multiplication, you might remember regarding signs that there's two different ways to get a positive number. You can always get a positive number by multiplying a positive times a positive. But you can also get a positive number by multiplying a negative times a negative. So when I'm deciding which signs I'm going to put in these parentheses, I have to have a way of breaking this tie. Well, in this particular situation where I have two possibilities, I'm going to allow the number in the middle, my b, to break the tie. And I could see that the number in the middle is positive. Therefore, I'm going to choose x plus x plus. Now, if we go over to this other one and do this other one simultaneously, and we go through the same process, I see that my last number is positive, which means it's a positive times a positive, or a negative times a negative. There's two ways to get a positive number multiplying. Well, I'm going to allow the number in the middle to be the tiebreaker, and it happens to be negative. So I'm going to put negative times a negative in this one. And now we get to the last part. What two numbers am I going to put to finish my problem? Well, we're going to go all the way back to, if you remember, when we're finding the factors of a number. And I'm going to take this last number onto my scrap paper, which is positive 20. And I'm going to make a little t-chart, and I'm going to write down all the factors of positive 20. Well, 1 times 20, it's an even number, so we have 2 times 10. 3 does not go in evenly, but 4 does, 5 times. Now, you might have noticed that I left this positive 20 on my t-chart, because what I'm looking for now are two numbers that not only multiply to give me positive 20, but add to give me positive 12, the number in the middle. Right? That's why we played the add them, multiply them game. Two numbers that add to positive 12, However, but also multiply to positive 20. Well, these factors all multiply to 20. So now I'm going to try each one, and I'm going to add 1 plus 20, and that's equal to 21. So that's not it. And then I get to the second one, which is 2 plus 10, which is 12. I found my two numbers that add to 12 and multiply to 20. And I already have the signs in my binomial, so all I need to do is put the 2 and the 10 in, and I'm done. Now, the quick check that I'm going to do is the game that we've been playing. I'm going to add them and multiply them. I want them to add to the middle number, and I want them to multiply to the last number. Positive 2 plus 10 is positive 12, check. And positive 2 times positive 10 is positive 20, check. This is my final answer. Well, let's get to the other scenario. Well, we're going to do exactly the same thing. I have my positive 20. I'll make my t-chart. We have our 1 times 20, our 2 times 10, our 4 times 5, and still have a positive 20 here because that last number is 20. So again, I'm doing exactly the same thing. A pair of numbers, a pair of factors of 20 that also add to 12. And we get the same 2 and 10. And since we already have the negatives in there, I'm going to put 2 and 10. I'm going to check it. A negative 2 plus a negative 10 is equal to negative 12. Check. And negative 2 times negative 10, remember, a negative times a negative is positive, is equal to positive 20. Check. And there's the answer there. Study these two problems and make note of their differences and similarities. Let's continue. Here's another pair of problems that are slightly different, but you might also notice that they look pretty similar to each other. We have an x squared plus 6x minus 16 and an x squared minus 6x minus 16. So let's start this problem the same way we did the other one with our two sets of parentheses. I'll do them simultaneously so we can see their differences. And we start with our x squared in each one. So I know I have my x times my x and my x times my x. And the next part of the problem is jumping to the last number, not necessarily the number as much as the sign. And it's a negative 16. And the other one is also negative 16. Now this next part might be a little bit easier for a moment. There's only one way, as far as signs go, to get a negative integer. And that's when I multiply a positive times a negative. Same with the other problem. So I could already go to both of those parentheses and put a positive in one and a negative in the other, a positive in one and a negative in the other, because the last number in each of them is negative. Now, just like the other problem, I'm going to take the last number with its sign. You'll see why I do that in a moment. And I'm going to write down all the factors of 16. Well, 1 times 16, 2 times 8, and 4 times 4. I'll do the other one at the same time. Why not? Since it's exactly the same numbers. 1 times 16, 2 times 8, 4 times 4. There's no difference there. Well, the reason why I bring down the negative in front of the 16 is kind of to remind myself that in a way I'm looking for two numbers that kind of subtract to give me the middle number, which is 6. So very quickly in my mind, I say 16 minus 1 is 15, so it can't be that one. Then I get 8 minus 2, and that happens to be equal to 6. So I found the pair. However, you need to pause right now and think about something very important. We can't just put these numbers in wherever we want because the signs are different. We have to be very, very careful. When we add these two numbers, they have to be equal to a positive 6. that tells me that the bigger of those two numbers, the 8, has to stay positive. So I'm going to put the 8 in the positive parentheses, and I'm going to put the 2 in the negative, and now I'm going to check my work. I'm going to add them and multiply them. Positive 8 plus negative 2 is positive 6, check. A positive 8 times a negative 2. Remember, a positive times a negative is equal to negative 16. This is my final answer. And if we go to the other problem, we're going to go through the same exact process. That negative in front of the 16 reminds me I'm kind of subtracting these. 16 minus 1, 15. I get the same two numbers. 8 minus 2 is 6. However, in this case, they need to add to a negative 6. Well, that tells me that the larger of the two numbers, which is still the 8, in this case needs to be negative. So I'm going to put the 8 with the negative parentheses and the 2 in the positive. And I'm going to check my work, mental check. A positive 2 plus a negative 8 is negative 6. And a positive 2 times a negative 8 is negative 16. So this is my final answer. Okay, let's see how you do with a little bit of practice. Here are 4 final problems. Here's what I'd like you to do for each one. After, I want you to pause the screen and try to do several different things. First of all, just by looking at the trinomial in each one, I want you to decide the 3 possibilities of signs. Are they both going to be positive? Are they both going to be negative? Or are they going to be different? Then I want you to go through the same exact process that we went through for each of the 4 previous examples and see if you can correctly factor each trinomial into 2 binomials. Go ahead, pause the screen. Okay, let's check your work. Here we go. X squared minus 5x plus 6. The first thing that I like to do is put in my x times my x. I go to the last number and I circle the sign. I see that it's positive, which means I have 2 possibilities. A positive positive or a negative negative. Well, I need a tiebreaker. So I look in the middle, I see it's negative, so I'm going to choose negative, negative. Let's do all the signs first. Why not? Let's go to the next one, just do the signs. So I have my x times my x. I jump to the last number. It's the sign that's important. Oh, it's negative. There's only one possibility, positive times a negative. Let's go to the bottom left problem. X squared minus 2x minus 24. Well, in this case, I'm going to start with my x times my x. That last number is negative. That means there's only one possibility. That's a positive times a negative. And the final problem, x squared plus 14x plus 40. I look at that last number. It's positive. That means there's 2 possibilities. So I use the tiebreaker of the middle. That's a positive 14. So I use a positive. Okay, let's go back and finish the first problem. Well, in this first problem, my last number is a positive 6. So it's going to be 1 times 6 or 2 times 3. This positive reminds me that I'm adding them to equal the middle number, which is 5. 1 plus 6 is 7. 2 plus 3 is 5. The signs are the same, so put in the numbers. Next, let's look at the negative 28. Put that on the side. I'm going to write down all the factors. 1 times 28, 2 times 14, 3 does not go in, but 4 times 7. This minus reminds me that I'm looking for 2 numbers that kind of subtract to give me the positive 3 in the middle. Well, 28 minus 1 is 27. 14 minus 2 is 12. 7 minus 4 is 3. However, be careful when the signs are different. The larger number is 7. The middle sign is positive. Those need to match. So it's going to be a positive 7 and a minus 4. Let's go to the bottom left. We have a negative 24. 1 times 24, 2 times 12, 3 times 8, and 4 times 6. The negative reminds me that I'm looking for numbers that kind of subtract to 2. Well, 24 minus 1, 23. 12 minus 2 is 10. 8 minus 3 is 5. 6 minus 4 is 2. However, be careful. When the signs are different, be careful. 6 is the larger of the two numbers. The middle sign is negative. Those need to match. So it's going to be a minus 6 and a positive 4. And then the last problem, we have a positive 40. That's 1 times 40, 2 times 20. 3 doesn't go in evenly, but 4 times 10, and 5 times 8. The positive reminds me that they need to add to the middle number. 1 plus 40 is 41. 2 plus 20 is 22. 4 plus 10 is 14. And when the signs are the same, we could just throw them in wherever we want. There's no difference. There you have it. Positive 4, positive 10. Now let's finish off by checking each one with mental math, which is nothing more than the add them, multiply them game. So I'm going to go to the first one, upper left. Negative 2 plus negative 3 is negative 5. Check. Negative 2 times negative 3 is positive 6. Check. That is my correct answer. Let's go to the top right. A positive 7 plus negative 4 is positive 3. Check. A positive 4 times negative 4 is negative 28. Check. That is my correct answer. Bottom left. A positive 4 plus a negative 6 is negative 2. Check. A positive 4 times negative 6 is negative 24. Check. That is my correct answer. And finally, 4 plus 10 is 14, and 4 times 10 is 40. This is also a correct answer, and that is how you factor trinomials.